Good morning, students. Today we are going to learn about irrational numbers, in which we will try to understand how to prove the number that it is an irrational number. Before moving towards the main concept, we will learn one theorem. The theorem says that if p is any prime number and p divides a square, then p divides a also. For example, suppose 5 is any prime number p and it divides 10 square, which is true. Then the theorem says that 5 divides 10 also. It is also true. 10 square is 100 and we can divide 100 by 5. On dividing we will get 20, and here we can divide 10 also by 5 and we will get 2. So understood that if we will take any prime number p and p is dividing a square, then we can say that p divides a also, where a is any positive integer. So just we have to remember that it is possible only for positive integers. Understood? Okay. Now we will move to the questions, which means how to prove a particular number as irrational number. Be attentive, that is an important part. I have taken to prove that root 7 is an irrational number. We will start with the contradiction and will prove that whatever we have assumed is not correct and hence it is an irrational number. So we will assume that root 7 is a rational number. It is just an assumption. Assume that root 7 is a rational number. We know that every rational number can be expressed in a by b form. P by q form we have studied. So let's take root 7 is equal to a by b, because already we know that root 7 is a rational number. We have assumed such that a and b have no common factor and b is not equal to 0. Okay, after doing this, we will square both the sides. On squaring, we will get 7 is equal to a square by b square. And then cross multiplication, we get 7b square is equal to a square. Got it? From here only, we can write b square is equal to a square by 7. We can write now. Now, what is b? B is an integer. Then what will be b square? B square will also be an integer, which means that a square by 7 is an integer. What is a square by 7? A square by 7 is an integer, which means that 7 divides a square. Getting my point? Since b square is an integer, which means a square by 7 is also an integer, and hence we can say that 7 divides a square. Let's move forward. Yeah, like this way, as I explained you that b square is an integer and b square is equal to a square by 7, and so a square by 7 is also an integer, and hence we can say that a square is divisible by 7. And just now we have learned that if a square is divisible by 7, then a is also divisible by 7. So a is also divisible by 7. So let's assume that a is equal to 7c, because if a is divisible by 7, which means A is a multiple of 7. So let us assume A is equal to 7C or 7D, 7E, 7Z, X, anything 7X you can take. Okay, so what we get, A is equal to 7C, and we will substitute the value of A in the equation 1. What we have the equation 1? Anyone remember? Yes, equation 1 is 7B square is equal to A square. So 7B square, and what is A? A is 7C, so here 7C square in place of this. So we get 7B square is equal to 49C square. And then by doing the calculation, we got B square is equal to 7C square. Again the same process. B square is equal to 7C square, which means B square by 7 is equal to C square. Now C is any integer, which means C square is a positive integer. So B square by 7 is also a positive integer. Since B square by 7 is an integer, which means that we can say that B square is divisible by 7, and hence B is also divisible by 7. Let's see what we get here. We get A is divisible by 7. Here we are getting B is divisible by 7. But what we have chosen? We have choose that A and B are integers such that they don't have any common factor other than 1. But we got A and B both are divisible by 7. The result which we are getting, which means that what we have assumed and what we are getting both are two different things. They cannot be same. Hence we come to the contradiction. And which arises that what we have assumed is wrong, and hence we can say that root 7 is an irrational number. Got it? Okay. Now here we have proved it for root 7. In the same way we can prove for root 2, root 3, root 5, and so on. Even we can prove for root P also, where P is a prime number. So whenever we will take any prime number inside the root, it becomes an irrational number. And how to prove that number as irrational number? The same way as we have proved root 7. Understood? Okay, now moving towards next. Now prove that 4 root 7 is an irrational number. These type of question also we will prove by contradiction method. Again we will assume that 4 root 7 is an irrational number. So what does it mean? There exist co-prime number A and B such that 4 root 7 is equal to A by B, or we get root 7 is equal to A by 4B. Now if we see the right hand side, A is an integer, 4 is an integer, and B is also an integer. So integer by integer, therefore A by 4B is a rational number. But already we know that root 7 is an irrational number. So we cannot say that an irrational number is equal to rational number. So it contradicts our fact that root 7 is an irrational number. Hence, 4 root 7 is an irrational number. Here it should be irrational. This contradicts that root 7 is irrational. We must change it. Understood? The same question 4 root 7 can be solved in alternate method also. Let's try that method. Now, in this method, what we know, 4 is a rational number and root 7 is an irrational number. Already we know it. And in previous class, we have studied that multiplication of rational number and irrational number always gives us irrational number. So 4 multiplied by root 7 is an irrational number. Hence 4 root 7 is an irrational number. So this is the way we have to prove that any particular number is irrational. The same method we can use for addition or subtraction also. Like if we have to prove 4 plus root 7 is an irrational, then again 4 is rational, root 7 is irrational. And we know that addition of, instead of multiplication, addition of two numbers, which one is rational and another is irrational, always gives us irrational number. So 4 plus root 7 is an irrational number. Same way we can do for subtraction also, yes. So let's move further. This is all about the rational number proving. Just the few key points you have to remember, that if p is any prime number which divides a square, then p divides a also, where a is a positive integer. And this also, rational number plus rational number is rational number. Rational number minus rational number is rational number. But rational number by rational number may or may not be a rational number. But if we change it, if we change little bit here, like if we take rational plus irrational, then it becomes irrational. Rational minus irrational. Irrational. Let us see one more question to prove that the given number is irrational number. Here we have taken it 3. We have to prove that 3 plus 2 root 5 is an irrational number. Till now, we understood that whenever we have to prove that particular number is irrational, we have to assume the opposite thing. So let us assume that 3 plus 2 root 5 is a rational number. Again, by definition of rational number, 3 plus 2 root 5 can be written as a by b, where a and b are co-prime number and b is not equal to 0. Always remember to mention this line, that a and b are co-prime number and b is not equal to 0. Now, the next trick is to shift every whole number from left side to right. So first we will shift 3. First we will shift 3 from left to right. It becomes minus 3. So it becomes 2 root 5 is equal to a by b minus 3. After that, we can write it as a minus 3b by b. Next step is to shift 2 also from left side to right. So we got root 5 is equal to a minus 3b by 2b. Now, according to our knowledge, root 5 is an irrational number. Got it? and we know that a is a integer, b is an integer, 3 is an integer. Here also 2 and b are integer, which means that this whole a minus 3b by 2b is a rational number. So what we get, root 5 an irrational number and a minus 3b by 2 a rational number, and this side one irrational number. Which means that rational number is equal to irrational number, but it is not possible because rational number is not equal to irrational number. Hence we come to the contradiction. What we have assumed is incorrect. Thus 3 plus 2 root 5 is irrational number. This is the one way we can prove that this number 3 plus 2 root 5 is an irrational number. The other way, the second method which I explained you, is that to prove the same question. Second method. What we know that root 5 is irrational number and 2 is rational. Then 2 root 5 will become irrational because sum of one rational number and irrational number is an irrational number. Sorry, product of irrational number to rational number is irrational number. So we got that 2 root 5 is an irrational number. Now we know that 3 is rational. So 3 plus 2 root 5 is irrational because sum of rational and irrational number is always irrational number. So by second way we will prove like this also, by simply saying that sum of rational and irrational number is rational, irrational number, product of rational and irrational number is irrational number. Same way we can say that subtraction of rational and irrational number is also a irrational numbers. So by this concept you can able to complete exercise 1.3. So students, please complete exercise 1.3, and for any doubt you can contact me. Till then, have a good day.